Today's lesson is on multiplying polynomials. Before we went on this break for distance learning, we had just finished section 6.4 where we were adding and subtracting polynomials. When we did that, we did not touch the exponents of the variables. They were all we just worried about combining like terms. We never touched the actual exponents. When we multiply monomials, polynomials, binomials, everything that's going to cover in this section, we do pay attention to those exponents. And there's special rules when you are multiplying variables with exponents. For the first section of problems, we are going to cover multiplying monomials. First, it's similar to distributing. 5 times 4 is 20. Then you're going to multiply your exponents. You have x squared times x cubed. That is a total. You add your exponents, which in this case would be 5. Over here on the right, the little reminder of something that you might have learned in middle school is when you multiply two variables that have the same base. So in this case, I just did that with two variables that they were both x. You add the exponents. So another example would be if I were to multiply x cubed times x to the 4th. That is going to give me x to the 7th because you add your exponents. You have a total number of 7 in this case. It's your total number of x's combined. Again, when we did adding and subtracting, we never touched the exponents of the variables. We just took care of adding and subtracting the coefficients. So now we got to take care of it all. You basically multiply everything together. Okay, let's try another one. -3 times 4 is -12. Now I have x cubed times x. You are going to visualize that is x to a power of 1. So again, when I multiply x cubed times x to the power of 1, that's going to give me 4 x's. So it's going to be x to a power of 4. Then I'm going to combine my y's. I've got y squared times y to the 5th. So y squared times y to the 5th is going to give me y to the 7th power. And this would be my final answer. All right, here I've got 3 monomials. The concept is the same, you're just multiplying by an additional number. So here, I know you guys are always scared of fractions. It's not that big of a deal in this circumstance. You are first going to multiply your two numbers, your constants. So I'm going to multiply 1/2 times 6. 1/2 times 6 is 3. So I take care of those two. Now I'm going to start working on the numbers. All of my a's. I've got a cubed times a squared. A cubed times a squared is a to the 5th power. Next, I've got my b's. I've got 1b here, which again, you're going to visualize as if it's got the 1 there. And then I've got b squared. So I've got b to the power of 1 times b squared. That gives me a total of 3 b's. So I have b cubed. And lastly, my c's. In this particular problem, there is only one c, and that is c squared. So now I have my colorful final answer. The next type of problem we're going to cover is when you have to multiply a polynomial by a monomial. Remember that a monomial is just one term, and a polynomial has many terms. So again, this, if you think back in middle school, this is a lot like multiplying or distributing a property or a number. When you distribute, you have to make sure that you distribute to every number in the set of parentheses. So I'm going to multiply 5 times 2x squared, which gives me 10x squared. Multiplying 5 times x is 5x, and multiplying 5 times 4 gives me 20. And that would be my final answer. If after you distribute, in this case, or multiply to everybody in the set of parentheses, if there was something like terms of any sort, you would take that extra step and combine any like terms. But in this problem, there are no like terms, so therefore I'm done with the answer that I put the box around. All right. Now, I just got more variables in this one, but the concept is the same. First, I'm going to multiply 2x squared y times 3x. That is going to give me 6x cubed times y. Again, I multiply the 2 and the 3. That gave me the 6. X squared times x gives me 3x's total, so that's why it's x cubed. And then I have a y. Next, I'm going to multiply 2x squared y times negative y. That is going to give me negative 2x squared y squared. The negative sign turns into a subtraction sign here because when it's written next to another term, it becomes subtraction. I only have x squared all by itself, but I am going to combine the y's. I have y to a power of 1 in the first and y to a power of 1 in the second. When I combine them, it becomes y squared. And these are not like terms, therefore I cannot go any further with simplifying, so this would be my final answer. All right. Normally this would be the time where I tell you to try it on your own, but we'll do it together again. Next, I'm going to multiply in this problem 4a times a squared times b. This is going to give me 4a cubed times b. The a cubed comes from 1a in the first one and 2a's in the second term. Next, I'm going to multiply 4a times positive 2b squared. Because they're both positive, I am going to have a plus sign here. I'm going to multiply my two coefficients, would give me 8. 4 times 2 is 8. Next, I have an a and a b squared. No adding of exponents here because I did not have the same base. And that would be my final answer. All right. Got a lot of variables. Technically, we only have 2 variables here. You're going to multiply 5r squared times s squared. The only thing that changes is 1r got added. So I'm going to add 2 plus 1, which will give me 3 r's total. The 5 and the s squared stay the same. Next, I'm going to multiply 5r squared s squared times 3s. Well, it's negative 3s actually. So again, I'm going to multiply 5r squared s squared times negative 3s. This will give me a negative, and 5 times 3 is 15. So negative 15. R squared stays the same. I have 2 s's here, 1 s here. It's going to give me s cubed. I'm done with this problem because I do not have like terms. They're similar, but they are raised. I have an r and an s, but they're different exponents in each term. All right, this is something you may, I don't know if it's going to be a good memory or a bad memory, but in middle school you did something called foiling. It's when you multiply 2 binomials. The letters in FOIL, F-O-I-L, F stands for first, O stands for outer, I stands for inner, L stands for last. When you go to multiply first, outer, inner, last, that is the process called foiling. I don't really care whether or not you know what each letter is. I just want you to be able to actually multiply the 2 binomials. So I am going to get a little colorful with my different colors here and notability in order to show you what each letter would be. So in the first round of multiplying, you are going to take the first term, hence the f, and you are going to multiply it to the first term in the second parentheses. So x times x is going to give me x squared. Next, I'm going to take that x and I am going to multiply it by the outer number 5 in this case. X times negative 5 is negative 5x. Next, I'm going to do the 2 inner numbers. 2 times x gives me 2x. And then, for my last multiplication, hence the L, 2 times negative 5 gives me negative 10. Now, in this circumstance, I do have like terms. I have negative 5x and positive 2x. So I am going to combine them. Negative 5 plus 3, it gives me negative 5 plus 2x gives me negative 3x. So I combine just those two like terms and I get my answer of x squared minus 3x minus 10. In my next example, it may look different, but what you would do here, simply separate x plus 4 squared into x plus 4 times x plus 4. And again, I'll get colorful here. My first, the f in FOIL, x times x is x squared. Then I'm going to do outer, the first times the outer. X times 4 gives me 4x. 4 times x is another 4x. And 4 times 4 is 16. Okay, again, I've got like terms, positive 4x, positive 4x. That will become my middle term. And here is your answer. All right, I will start to show you a bit of a shortcut in these ones if you can handle it. If not, you go back straight up to foiling where you do the math out. The shortcut, we'll go pink for my shortcut. My shortcut is always going to be, the first term is going to be x squared. To get the middle term, you simply add the two second terms. So in this case, I have negative 6 plus negative 2. That would give me negative 8x. And lastly, you would multiply the last two terms. Negative 6 times negative 2 gives me positive 12. And that would be my answer if you wanted to do a shortcut. If you're uncomfortable with the shortcut, then you simply go back to foiling the problem step by step. So here, x times x gives me x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x, and negative 2x times negative 6 is positive 12. Lastly, you're going to combine your like terms, and as you can see, I get this same exact answer I did when I did the shortcut. So we'll try another shortcut on this next one. Again, for my it's always going to start with x squared, taking the first term in the set of parentheses and squaring them. Next, you're going to add the two other terms. I'm going to add 12 and I'm going to add 1. That's going to give me 13x. Those same two numbers that I added to give me 13, I'm now going to multiply them, and that gives me my third term of 12. That would be a shortcut, doing it mostly in your head. Again, you don't like it, you haven't picked up on the shortcut, then you're simply going to multiply these out, foiling. X times x is x squared, x times 12 is 12x, 1 times x is x, and 1 times 12 is 12. Add these up, x squared plus 13x plus 12. Once again, the answer is exactly the same as it was whether you use the shortcut or not. Okay. This problem, we got more variables, but the foiling is still there. You're going to take the first two terms and multiply them. 3a squared times a squared gives me 3a to the fourth. (3a) times negative 2b is negative 6a squared times b. The two inner ones makes a cute little smiley face when you draw that in there. You have negative a squared times b. And the last one is negative b times negative 2b. You have to pay attention to the signs that are in front of there, because in this circumstance, that last term, that blue term, became positive because you multiplied two negatives together. Last thing is going to be, it's usually going to be always be your last term, last step I should say, is you're going to combine your like terms. So your final answer here is 3a to the fourth minus 7a squared b plus 2b squared. When you're multiplying binomials, you're always going to have being able to combine the